All right, welcome to Blue Pen Land. Don't you guys have like cat videos you should be watching or something like that? Okay, so this guy is going to we're going to launch this guy at some angle. 75 degrees is pretty tall like that, right? And this is 27.2 meters per second, right? And this angle here is 75 degrees, right? Okay, so we can't do anything with that because it's not all in the x and it's not all in the y, right? So what we got to do is we got to bust that into components. We got to break this guy into components, right? So we got to figure out what its horizontal is here, right? We got to figure out what its vertical is there, right? So this is the opposite side, so that's going to be 27.2 sine 75, right? And then this side here is going to be 27.2 cos 75. Okay, so let's bust that out. 27.2 sine 75, 26.27. Yeah, and then let's bust this guy out here. 27.2 cos 75. 7.039, so 7.040. Let's carry 3 digits, right? 3 ought to be enough, right? Okay, so those guys go in here. That's this guy, 7.040, right? This will be 7.040, right? So that horizontal part is what it always is, right? The initial vertical velocity is 26.27, right? This is 0, this is negative 9.8. And then all of these guys, right, we're on a horizontal, on a level field, right? So this is 0. There's no net change in elevation, right? We've got a field like this, right? It's like, right? We start at the same elevation that we end, right? So that's 0, which means that this final velocity is negative 26.27. All right, so now we've got all these numbers here, right? So we got 26.27, and this side's solvable. You always use this. Always go VF is VI plus AT. They're all the same. So negative 26.27 is 26.27 minus 9.8 times the time, right? So now we can solve for time. Let's see. So I'm going to go this. I'm going to add this onto the side. So we'll get twice 26.27, right? And then divide by 9.8. And I get 5.362 seconds, right? That's the time it's in the air, right? And then that time goes across, right? And now we can figure out the distance here, right? It's going to be, all we do is x is vt, right? So we cover up the x and it's vt. So this times this, right? So that times is 37.75. 746, right? Okay. Let's see, so 37.7 meters, that's how far it goes. It's 5.36 seconds in the air, right? Greatest height, how do you do that, right? Okay, so greatest height, you just got to set up another little vertical thing here, right? So let's get ourselves a little room here, right? Vertically, we just go x, vi, vf, a, and t, right? And we say our initial velocity is this guy, right? 26.27. And then at the top, right, at the very top, okay, the final velocity is 0. This guy's negative 9.8, right? And so what we're going to do is we're going to use VF squared is VI squared plus 2AX, okay? Only the final velocity is 0. So 0 squared is, 26.27 squared plus 2 times negative 9.8 times x is what we're trying to solve for, right? So that's going to be this guy squared, right? Divided by 2 divided by 9.8. I'm getting 35.2 for x. Right? So that's the greatest height. That's the greatest height. So this picture's not really quite to scale, right? 35.2 is how high it gets. And then why is the velocity 7.04? Well, at the highest point, right, it's got a velocity of 7.04, right, meters per second in the x direction. And that's this guy, right? In the y direction, right, it's got 0 meters per second because it's at the top, it's going 0, right, in the y direction. So its speed right here is just simply its horizontal velocity, whatever it is, right? So that's just a trick question. It's always just whatever that horizontal velocity is, okay?